breach of confidentiality that could be happen in the cloud environment. Okay. Then we have discussed the integrity. In integrity, we have seen that if there is a loss of data or manipulation of the data, that is considered as an integrity breach. And not only we have discussed about the integrity of data, we have also seen that since the cloud servers perform or provide storage facility and the computation facility, that is why we have seen not only the data uh, integrity of data, we have also seen the integrity of computation. Okay, so today we will see like what could be the defense strategy through which we can ensure the data integrity. After that, our discussion proceed towards the cloud availability. In the cloud availability, we had seen bandwidth under provisioning could be possible, through which starvation will be happen over the link, and it will not possible for the cloud service user to access the cloud services. Another kind of vulnerability that arises is because of the cloud pricing model. So in the cloud pricing model, as you know, like we pay what we use. Okay, like it is like per hour basis or per minute basis or per second basis of every service. So if you are using a service for T amount of time, and that is multiplied by some R amount of price. So T multiplied by R, in this way, the prices are calculated for each and every service. But if an uh, attack happen on some of the services, okay, and that service has not reached to that level, that service has halt, okay, and that particular attack, that you are not able to distinguish between the attack that is legitimate attack and another thing is like a true user of your service. Okay, in that way you are still paying the bill. So these kind of things possible that we have discussed yesterday. And finally, the cloud accountability, where we have seen since we are outsourcing our data and computation to a third party cloud server, and there is a trust deficit between the cloud service provider and the cloud user. So a loss of physical control and loss of transparency happen in the case of cloud accountability. Then we will discuss uh, the things which happen due to the cloud accountability. So let's start today's presentation. Okay, so that is the quick recap that we have done in the previous day. Today we are going towards like deeper in the cloud confidentiality, integrity, availability, and accountability. Okay, so first I will discuss the cloud confidentiality. Then we will see the threat model or the threats in the cloud confidentiality. And due to that threat or due to that vulnerability, the adversaries are exploiting those vulnerability, and then threat arise and they perform a kind of attack that is known as cross VM attack. VM means virtual machine, and the full form of VM is virtual machine. So virtual machines are launched over the physical machine, and since multiple VMs are resided on a single physical machine due to multi-tenancy nature of the cloud computing, such kind of attack may possible. Further, malicious system admin. We will discuss about the malicious system admin. If the employee become disgruntled, if if a cloud service provider's employee want to steal some data in the part of for the personal gain or in the part of corporate spionage, then how we can handle such kind of attack. Then we will see multiple kind of defense strategies, the placement prevention, co-residence detection, no hypervisor, trusted cloud computing platform, and retaining the data control back to the customers. Okay, so we will see one by one all these topics in today's presentation. Okay, guys. Okay, let's start. So as you know, confidentiality deal with preventing unauthorized user from accessing the data. Okay, and cloud confidentiality implies that a customer data and computation tasks are to be kept confidential from both the cloud providers and from the other customer. And this is an important point, because whenever we are discussing about the confidentiality, we we thought, since we are communicating or performing work over the cloud, so there is a trust between the cloud service provider and the cloud service user. But here what you see that there is a trust deficit between the cloud service provider and the cloud user, and therefore we try to we try to make our data confidential even with the cloud service provider. We do not want to reveal any information to the cloud service provider. Okay, and therefore, since cloud is also a third party and there is a trust deficit between the cloud service provider and the cloud user, so confidentiality remains the greatest concern from the cloud service user. Further, in the cloud service provider, since it's provide both the storage facility and the computational facility, therefore it becomes important to provide data confidentiality and the application security. Okay, you do not want to breach the data which is computed or produced during the processing of that data. Means if there is an application which had performed some kind of process on the data which is stored on the cloud. Okay, so you have initiated some prevention mechanism through which you are ensuring data confidentiality. But at the same time, it was not possible to ensure the confidentiality of the output of the result. Okay, so in the end, there is a confidentiality breach. So what you have to do, you have to make certain mechanism through which you are getting the data confidentiality, and also the retaining the confidentiality of the result produced in the cloud system. Okay, further, any breach in the security can lead to penalties resulting from sensitive information disclosure and damage from the company's reputation. The reason being, in today's environment, most of the companies, whether it's a small company or a bigger company, and even from across all the domain, means from financial domain, from healthcare domain, and even from other domains which previously never shared their data, they also sharing their data to the cloud because it is not possible on their end to perform a large computation over a used data. Are you getting my point? The reason being, guys, you people are able to hear me? Everyone?
Yes, yes.
Okay,
Yes, sir. Yes, sir.
Yes, Professor,
okay,
please go ahead.
okay, okay. So here what happened? There are multiple domains, and more importantly, the financial domain and the healthcare domain, where the information is sensitive in nature, or even you can say that there is some startup who is entirely using the cloud computing platform. And since it's a startup, maybe they have some novel idea, some new idea which is not yet presented in the market, and they are using the cloud platform for a storage service, for computation service, or all kind of their computational needs. And that information has been breached and sell out in the market. Okay, so because of that, it will be jeopardize entire business of that company. Okay, and that is why the confidentiality became one of the important thing while using the cloud computing. Further, the cloud service providers provide registration to any person because they are the public cloud providers, and most of them provide the registration free of cost, that they will allow you to onboard their system free of cost. In this way, there is a very lesser way where one can discriminate between a legitimate user or a hacker. or adversary. Okay, and all of them boarded to the cloud environment. Okay, and later on, the hackers or the adversaries try to exploit the vulnerabilities of the cloud. So let's try to see the VM co-residency. Okay, so now I'm going to discuss few of the vulnerabilities, and these vulnerabilities we have already discussed in the previous slides also. So I'm just try to recap them so that we are able to make a correlation when we will discuss about the threat model. Okay. So VM co-residence. So VM co-residence means a cloud cloud provide a multi-tenancy. Multi-tenancy means on a single physical system, multiple individual users or multiple VMs, virtual machines are launched, or their co-resides on a single machine. And that opens door for vulnerability that could be exploited by the adversaries. Okay. And the confidentiality issue maybe not only arises because of the multi-tenancy property, it could be arise arise due to the malicious system admin. If uh, if a employee if an employee of a cloud service provider become disgruntled or become malicious in nature due to bribe or sometime due to personal gain or due to the effect of corporate espionage, means some other competitor company has hired that employee to perform a corporate espionage over some of the client, so that could be possible. Okay. Another reason for confidentiality issue will is that data and program is outsourced to the cloud server. As a result, the owner of the data lose direct control over the datasets and the program. And loss of physical control means that customers are not able to restrain certain attack and accidents. For example, data or software may be altered, lost, or even deleted. In addition, it is difficult and impractical to ensure data computation, integrity, and confidentiality with traditional methods. The reason being the size of the data and the size of the computation is so large that the traditional method of hashing is not possible. If you perform such kind of hashing over such a large data, it required a huge amount of computation. As in the cloud, we always assume that client have a limited uh, computing environment or limited computing resources, and that is why it is using the facility of the cloud computing. So at their end, it is not possible to perform such a huge computation. And in the same way, when we are talking about the computational integrity, since the computation is performed over the cloud servers, and it's performed over a huge amount of data, so definitely you don't have any result so that you can compare the output of the result. So it is not possible to perform at your end the same kind of computation and compare the result. Okay, so that is why it's become a challenge for the research community to come with novel way to provide data integrity and computational integrity. Okay, so further we have seen in the accountability different kind of DOS and DDoS attack, which due to that bandwidth under provisioning or starvation of the link could happen, and even a legitimate user is not able to use the services of the cloud. So a data center is usually designed to be under provisioned with a factor of 2.5 to 8 to up to 8 in the ratio of 8 is to 1, meaning that the actual network capacity is much lesser than the aggregate capacity of the host located in the subnet. But it is always assumed that all the hosts will never be online at the same time. Okay, that all the hosts will never be online at the same time. and that is why these kind of factors is provisioned to save the cost of save cost on the infrastructure. Okay, but if the certain kind of attack happen, if the certain kind of attack happen at that time, they will use these bottleneck, these bottleneck to perform the attack. And if they are using these bottleneck to perform such kind of attack, definitely the bandwidth will be starved, the link will be starved, and a legitimate user will not able to use a certain kind of services. Then further, the cloud pricing model. In the cloud pricing model, as you know, that cloud computing adheres the pay as per you go pricing model, means whenever you are going to use a certain kind of service. Okay, so most of the services are per hour basis. Okay, and the amount of time you are using that service and multiplied by the rate, you have to pay that. But if an attack happen, okay, and the service is consumed by the adversary rather than by your clients, and you are not able to distinguish between the client and the legitimate users. So even if your users are not using that service, that is why the user is not paying you, but you have to pay to the cloud service provider. So that kind of things may be happen. So guys, before going to discuss the cross VM attack via side channel, okay, I want to discuss about the virtual machines. I want to discuss about the virtualization and the virtual machine, because I don't know, like every one of you are aware about the virtualization technology and the virtual machines or not. So I'm just quickly cover up the virtualization technique and the virtual machines. So we'll come to these slides again and then continue. Okay, so for the time being, I'm just going to quickly cover the virtualization and the virtual machines. Okay, so in the virtualization, before going to discuss anything, this one is a real world example of the virtualization. So just try to observe these two pictures. The definition of virtualization will automatically come into the mind. Okay. So whenever you go in the market and try to eat a pizza, what you do? You go into the Domino's outlet and order the pizza and then eat it. So that particular pizza outlet is a physical one. It is made up of brick and mortar. Okay. However, if the same outlet come as an application on your mobile phone, means we have virtualized the entire experience. We have virtualized the entire outlet as an application and given to you in the phone. And even from that phone, you are allowed to order and perform any kind of customization which you are able to do personally in the physical outlet. So that is virtualized. Now the entire outlet has been virtualized. Similarly, when you have the physical currencies, when you are paying the physical currencies, when you are paying the physical currency for any particular service or any good, that is a physical way of doing the business. Another thing is that you are able to use different kind of payment services, online payment services, or the card services, or the uh, internet banking for the same purpose. Are you getting my point? That is the physical way of doing business, and another is the virtualized way of doing the business. And This same concept and the same concept is implemented in the cloud computing. In the cloud computing, the same concept is implemented. That is, previously, whenever we have to use a computing service, we have to purchase a laptop or desktop or anything. Okay. So consider the laptop or desktop or the mobile phone as a computing node, as a computing node. So let's say if you want water in your home, what you do? There is a pipeline, and then finally there is a tap, and water is coming out of that. Similarly, if you want to use the internet services, so at least you want a minimum computing node. So these are the devices which are the minimum computing node to perform the computation. Similarly, if you want electricity in your house and want to use the electric appliances in your house, what you do? There is a electricity coming from the uh, electricity grid to your house, and then there are multiple appliances which are running on the electricity. Similarly, these computing appliances running over the internet. Okay, so are you getting the similarity between them? My point is that now we have reached to that stage where a computing services is you can use the computing services as a utility services. Okay, utility service means when you are using it, you are paying it, and when you are using their services, you are paying for that. Okay, and they become so natural that they are flowing from any point, any like a pipeline method or any particular where method through which you are able to access those services. In the similar fashion, whenever you want to use any very high-end computing services, you just need a bare computing node. From that bare computing node, you are able to launch whatever you want, whatever kind of computing services you need. Okay, although your personal laptop or desktop doesn't have uh, a high-end GPU unit, a graphical processor unit, or a CPU unit, but you are allowed to use those things using the services of the cloud. That's what I want to say. Okay, so there is no need that you physically install a GPU in your system. You are allowed to use virtually the GPU in the cloud system. I hope this makes clear to everyone. Next, this is the typical server or system. Okay, where there is an hardware. This is the typical server in the system, and first there is a physical unit. First, there is a physical unit, means all the physical hardwares resided in the bottom of the layer, and over that you first install the operating system. As in all the system, you have in your desktop or in the laptop, you have physical hardwares. Over the physical hardware, the first thing is that you install the operating system. Once you have installed the operating system provide you the environment where you can install multiple kind of applications simultaneously and complete your work or the services. Are you getting the point? So how the virtualization is different from this? So in the virtualization, what happened? There is a hardware. In the hardware, in virtualization, similar to the previous example, hardware unit, and in the hardware unit, first you install the virtualization software rather than operating system. You are allowed to install the hypervisor. These virtualization softwares are known as hypervisors. So you will install the hypervisor. The hypervisor has performed the hypervisor has performed the virtualization of the physical resources. The virtualization of the physical resources. Once the virtualization of the physical resource happen, now you are allowed to install multiple system within a system. So each virtual machine perform as a separate system on a single physical environment. Okay. So as in statistics, most of the system that we are using in our houses, personally, sorry, not houses, personally, like laptops or desktop, they are used up to 10 to 20%. Most of the time they are sitting idle. Why I'm saying that? Like if you are using your personal computer or a laptop, how many hours you are using in a day? So most of us, maybe sometimes in a week or sometime in a month, maybe we are using it up to 8 hours or 10 hours, but most of the time we are not using them more than 4 hours, 5 hours, 2 hours, 1 hour, or depends upon the uses. And even we are using for 10 hours or 8 hours, even at that time, if you see the CPU utilization of your system, the utilization of the CPU will never be more than 10% or 20%. Means you are not using the computational capability of your system, and most of the time it is idle. And that was the concept that has coined when the cloud computing has realized in the year of 2000 to 2005, because uh, at that time Amazon was in the marketplace market, in the e-commerce market, and they have huge servers. They have huge servers around the North America to cater their customers. So what their engineers observed, that most of the time these servers remains idle because it is not possible that they are utilization to their peak capacity. So the they thought, why not we rented out these softwares, these servers. So at that time they thought that let's virtualize all the physical resources and offer them as a service, and in this way the cloud concept come into the market. Okay, so there are two ways through which this virtualization is possible. The first way is to install the virtualization directly over the hardware. Okay, that is known as a bare metal, virtualization. Another method through which virtualization is provided, that is, there is a hardware as usual, and then you install an operating system. So most of the time when we try to virtualize, provide a virtualization in our system, it is like that: there is a hardware, then a operating system is already installed, whether it's a Windows or Linux or Mac OS. After that, after that, and after that, we try to provide the facilities of the virtual machines. Guys, just a minute. I am pausing for just a minute.
Melissa, is all good?
Shika madam, he said that he will come back in 2 minutes.
Now we are continuing. So there are two ways through which we provide the virtualization. So on the lowest layer, it is always the physical systems. It is always the hardwares. Okay. And on the upper layer, it is either you directly install a virtualized layer, or first you install the operating system, then you install the virtualization layer, and after that the multiple virtual machine could be launched. Okay. So there are few definitions for virtualization. A virtual machine can be virtualized all of the hardware resources, including processors, memory, storage, and network connectivity. A virtual machine monitor, which commonly known as hypervisor, okay, is a software that provides the environment in which the virtual machines operate. Okay, so like you install the operating system, and once you have installed the operating system, you are allowed to install multiple application, because an operating system provide the requirement environment to execute an application. In the same way, the hypervisor or the virtualization layer provides you the environment in which multiple machines with multiple operating system. It is not like you have installed an operating system, let's say Windows, and over it you have installed a virtualization layer. So over the virtualization layer, it allow you to launch all kind of machines, whether it's a Linux, Windows, or any operating system. Okay, so that's all about the virtualization. Okay, and let's cover this slide also. In virtualized environment, there are three major components. That is the guest. Guest means the VMs that you are initiating. The host. Host means the operating system on which the virtualization layer is installed. Okay, so the guest represent the system component that interacts with the virtualization layer. So on the top of the layer, there will be the guest, the multiple VMs. The host represents the original environment where the guest is supposed to be managed, means the host operating system where you are installing the virtualization layer. And the virtualization layer is responsible for recreating the same or different environment where guest will be operate. So that's a small uh, introduction about the virtualization. I hope you people are able to understand about the virtualization. So now I'm going to continue where I have left the security and privacy presentation. Okay. So let's discuss about the cross virtual machine attack via side channels. So how these kind of attacks happen? So a scientist known as Risenpart, he has discussed in a seminal paper where he has demonstrated that a cross-channel VM attack could be possible. In that attack, a cross VM attack exploits the nature of multi-tenancy. So, which enables VMs belonging to different customers may co-resides on the same physical machine. Also, regarding the timing of the side channel as an insidious threat to the cloud computing security due to the fact that the timing channel perceivably exist and are hard to control due to the nature of massive parallelism and shared infrastructure. Okay, so the malicious customers that are able to steal the informations from other ones without leaving a trail or raising the exam are raising the alarms. Okay, so the point is that since the entire platform provides you the multi-tenancy, means it is shared between multiple customers. So that is why the victim virtual machine and the attacker's virtual machines both are on the same platform. Both are resides on the same platform. Okay, and they are able to exploit the vulnerabilities. Further, how one can initiate such kind of attacks? Guys, are you able to hear everyone?
Yes, sir. Yes, please go ahead.
Okay, okay, ma'am. Yeah. So how these kind of attacks could be possible? So the main point in that is the placement of the virtual machine. I am multiple time repeated that attack will only possible if the victim virtual machine and the adversary virtual machine are resided on the same physical machine. Then only the attack is possible. But how the such kind of placement will happen? How an adversary will place a virtual machine on the same machine where a victim virtual machine is also running? So for such kind of placement, an adversary need to place a malicious VM on the physical server where the target client virtual machine is also located. Okay. To achieve this, an adversary should first determine where the target virtual machine instance is located. Okay. So this could be done using the network probing tools. So there are multiple network probing tools such as Nmap, hping, and wjet. So using that, they try to identify the victim or the target virtual machine. Okay. After that, what they do, they try to compare the domain IP addresses of the two virtual machines. Okay, and once they are trying to compare with the IP addresses of the two virtual machine, which incidentally falls in the same subnet, on the same subnet, so they are trying to find out these things. Okay, further, they also try to check the co-residents. What they do, they transmit messages between the instances via the covert channels. Okay, further, they transmit the messages and try to measure the round trip time. Okay, try to measure the round trip time. If both the messages are takes same amount of time, it is possible they are hosted on the same machine. Okay, further, a malicious VM instance must be created on the target physical machine by specifying a set of parameters like zone and host type. That is also possible. Although till now we have not discussed about the zones and the host type. So whenever in the public cloud environment, whenever you launch any service, that particular service is launched in some of the zones, and a cloud environment is divided in multiple zones around the globe. Okay, so you can say like in AWS cloud there are multiple zones. You some 8 or 10 zones are there where the services are launched. So whenever you launch the service, it will launch in one of the zone of from 1 to 10. And also, if there is an adversary, they can specifically decide, okay, this particular virtual machine is launched in that zone, so it will choose that zone. And after that, it also choose the host type. So it is not like uh, necessarily that the adversary VM will launch on that physical machine, but at least it will launch on the same zone. Next, is that there are two basic strategies to launch a virtual machine. The first is brute force strategy, which simply launches many VM instances and check the co-residence with the target machine. Number two, an adversary can exploit the tendency that EC2 launches new instances on the small set of physical machines. Okay, so that is the localization reference. Means if that physical machine is launched on some server S1, so it may be possible the immediately launched virtual machine will also launch on the same server. Okay, the second strategy takes advantage of the EC2 VM assigning algorithm, because the EC2's VM assigning algorithm has been written in the same way that by starting a malicious VM after a victim VM, means back to back, the initialization of the virtual machines happen is launched, so that they will likely to be assigned on the same physical machine, and it have a better success rate. Okay guys, I hope you are getting the point, how adversary launch the VM and uh, try to get ways so that both the same virtual machines on the same physical machine. How it is not always possible, but there are multiple ways through which it could be achieved. Okay, so now the virtual machine has been launched. The next thing is like how it will exploit this vulnerability, how this will extract some meaningful information from that. So the first thing that the adversary virtual machine will do, that it will measure a cache usage. It will measure the cache usage that can estimate the current load on the server. Number two, it will also perform an estimation on the traffic rate that can obtain the visitor counts or even the frequently requested pages. And last, it is try to note the keystroke timing to try to steal the passwords. Okay, so a keystroke timing attack that can steal the victim password by measuring the time between the keystrokes. So that could be possible. These kind of things could be possible whenever a cross VM attack happens. Okay, the next thing is malicious system admin. An attack often initiated by an insider is theft of sensitive information, resulting in loss of data confidentiality and integrity. So in the cross VM attack that we have discussed, how an adversary may violate confidentiality of the cloud customers that co-residing with the victim virtual machine. Okay, But a malicious system administrator of the cloud service provider can perform attacks by accessing the memory of the customer's virtual machine, because a system admin have all the access. A system admin have all the access. Okay, even a system admin to directly access the virtual machine at runtime by running a user level processes. Okay, so they try to read all the memory access and also the data that is stored over the cloud. Okay, so sorry, this threat may be motivated financially, a common motivator for theft of intellectual property or fraud. But another attack possible is to consider the IT sabotage, where employees seeks to harm an employer's IT infrastructure. Okay, so what will happen that a cloud service provider has fired an employee, and before it is completing the its notice period or something like that, is try to just sabotage its entire IT infrastructure, and that is why uh, he is doing such kind of attack. And also the third thing is, if that particular employee is a part of corporate espionage, so also it is trying to steal the data. So now I'm going to an incidence, going to discuss an incidence which I have taken from CERT database. Okay, on the from the CERT database. So this was happened that an insider was employed as a system administrator. Just hear carefully. An insider was employed as a system administrator at a data mining firm contracted by a victim organization to process customer information. Okay, so through unnecessary of the job function, the insider had to access to the servers and the data owned by the victim organization. Then what happened? An unprotected file containing encrypted password informations was found on one of these servers. So that system admin performed an brute force attack over 300 passwords and accessed the data belonging to dozens of customers of victim organizations and downloaded millions of personal records. Okay, so this incident was happened on the CERT, and it is noted in the CERT by the CERT response team, and it is in the database. So these kind of things regularly happen in the cloud environment. But fortunately, the insider was arrested before the information was sold or released. So this was quoted, and that is why I has put in this slide, so that you will able to know what happens in the real world. Another incident that we have noted. Okay, so one other incident which happens, that an employee in the victim organization was tricked by a malicious outsider into opening a document infected with the malware. So it is something like that, that there are two friends. Okay, and one friend has malicious intention, so he have convinced the other friend who is working with the cloud service provider to open a file which is infected from the malware. Okay, the attacker was eventually able to gain access to the organization's email service hosted by the cloud service provider. Through aware of the attack in the progress, okay, aware of the attack in progress, the victim organization was unable to terminate the email service quickly enough to prevent the sensitive data loss. The reason being, since this attack was happened from the authorized user credentials of the company's employee. Okay, because that malware has injected into the organization from that particular employee. Okay, and even that employee don't know that this has happened. Okay, so even the security professional that is employed in the company, they know that some kind of attack happened, but they think, okay, that happened from an authorized user, from an authorized employee, so they just ignore that. And delay this delay was exacerbated by the inability of the organization to validate its identity with the cloud provider support personnel. Okay, so these kind of attacks regularly happen because of the human errors, because of the insiders, because of the malicious system admin or some disgruntled employee or some other thing. So it is not always a technical thing. It may be happen that a data centers is always guarded by men with all kind of ammunitions and everything. But something happen, let's say some uh, incidents happen, some accident happen, and rather than the technical one, let's there is a fire happen in the data center, or someone has stolen some of the disk or some of the drives. That kind of things also happen. Okay, there are incidents. If you like search on the Google, you will find out that these kind of physical activities also happen, which is responsible for the cloud outage, or which is responsible for confidentiality breach, integrity breach, availability breach. So these kind of things also possible. Okay, so now let's discuss the defense strategy. Okay, so there are multiple defense strategies through which we can uh, reduce the cross-channel VM attack. Okay, so there are many, but they are most of them are the research topics. Okay, so we will discuss some of the prevention mechanism and leaving others. And if you have interested in that, you can search it out and perform research on that. Okay, so the first thing is that placement prevention intends to reduce the success rate of placement. Okay, so we will implement some of the mechanism so that an adversary, it will be very hard for the adversary or near to be impossible for an adversary to perform the placement of their malicious virtual machine to the target VM. Another thing is that we will force physical isolation. Okay, that a virtual machine is initiated on an isolated server rather than on a shared architecture. Then there are new cache designs so that reading of data from the cache is not possible even if uh, attack has been launched, and the system where the target and the victim, where the target virtual machine and the adversary virtual machine has resided. Further, fuzzy time intends to weaken the malicious virtual machine's ability to receive the signal by eliminating the fine grained timers. Then forced virtual machine determinism ensure no timing or other non-deterministic information leaking to adversaries. And finally, cryptographic implementation of time resistant cache. Okay, so we will cryptographically encrypt all the data. Okay, so that none of the adversary able to read any kind of information. So these are the multiple kind of different strategies, and many of them are still under development. Okay, still there are some flaw over the period, and new techniques or new mechanism come into the academic domain and then in the market domains. Okay, so let's start few of them, discussion of some of them. So the first one is the placement prevention. In order to reduce the risk caused by shared infrastructure, what this mechanism say, the cloud provider may obfuscate the cloud provider obfuscate the co-residence by having domain 0 not to respond in the trace route and or by randomly assigning internal IP addresses to the launched VMs. Okay, means that whenever a network probe happens, like from whenever a network probe happen, like we have discussed the multiple kind of network probing tools, nnet and other kind of network probing tools, so they perform some or other kind of request, so they are able to get some kind of uh, information of zone of subnetwork or networking information, so that the target VM could be identified and placement could be happen. So for that purpose, the one thing that even such kind of request is generated, it's the server's responsibility where the target VM is reside not to respond to these kind of requests. Another thing, the cloud provider might let the users to decide. The another thing is to randomly give the physical machine. The cloud provider given the flexibility to the cloud service user that you randomly decide the physical machine and reside. So in this way, the randomness induced by the programs may be sometime detected by the adversaries. But if the randomness is induced by the cloud service user, it is possible, probably possible, that the adversary might not able to detect the physical location of the machine. Are you getting the point? The first thing is that it not respond to the trace route request. Whenever a response happens, simply silent. Now, no reply from the servers. Another thing is the cloud provider might let the user to decide where to put the VM. Okay, where to put the VM. However, this method have also flaw that when a brute force strategy is implied, means a VM could be multiple VM could be launched, okay, to find out the target VM. Eventually, one of the adversary VM resides on the target VM, reside on the same physical infrastructure of the target VM. Okay. So another method, another defense strategy is to avoid the co-residency. The first suggestion is that to eliminate the co-residency. Okay, whenever you have to launch a VM, launch on a isolated machine. Don't launch on a shared physical infrastructure. Okay, don't launch on the shared physical infrastructure. Further, cloud customers, especially the enterprises, the bigger enterprises, may require physical isolation. Okay, because they are paying for that. And many of the time it is written in the service level agreements. However, cloud vendors to make extra money, because not all the time the resources that is granted for an enterprise is in use. If they are vacant or not in use or idle, at that time the cloud vendor may be offered to some of the servers to other customers. And also you know that the operation happen inside the cloud is not transparent to the cloud service user, so at that time they could offer. Okay, so although it is agreed that the operations perform on a physical isolation. So they are providing physical isolation at a time when some or other process of that enterprise or that user is executing. But what happens when that user is not using some of the physical servers? So at that time, the cloud service provider is offering to the users. And if at that time, adversary has injected some of the malware, so when the enterprise actual execution happen and their data will be compromised. Another thing, another suggestion is that, okay, let's have the shared physical infrastructure. Let's have the shared physical infrastructure, but sharing happens only with the friendly virtual machine. The friendly virtual machine, or you can say the reputed virtual machine. So what is mean by that? Is mean by that let's say there are some reputed companies in the market. So let's say the Infosys and the TCS. Okay, so they are the reputed companies in the market. So the cloud service provider and the users both have a sense of belief in them, sense of trust in them, that they will never perform any kind of attack. So such friendly VMs could be launched on same physical infrastructure. Okay. Further, there are some software which ensure the physical isolation. Okay, like in the service level agreement, the cloud service provider has agreed to provide the physical isolation. But how the customer will verify whether the cloud service provider has providing the physical isolation? So for that purpose, there are some tools, that is Home Alone, known as Home Alone, which detects the co-residency by employing a side channel attack. Okay, so this is a detection tool which also perform a cloud side channel attack to identify whether the VM machine is executing in an isolated environment or it is executing with some other uh, virtual machine also. Okay, so guys, if you have any doubt in this session, you can ask me. I'm uh, pausing here for the next session. Hello, guys, any doubt till now what we have discussed? Okay, so I am taking pausing for some time. Then we will continue after some time.
Right. So what time do you want to have the next session?
Like as per schedule, it is
12, yeah.
from 12.
Okay, sure, sir.
Okay, so I will continue at 12 o'clock. Thank you
Perfect.
everyone for joining me.
Thank you, sir. Hello, Professor Malay.
Yes, ma'am.
So I request you to please share the presentations for the lectures yesterday so that we can
Okay.
share it with the participants also, because many of them have requested for the same.
Okay, so like it is required to share the presentation. Actually, I made all of them. So like, is it okay to like share the presentation?
It should be okay, sir.
Okay, I will share it. No problem.
Okay.
Because most of the time, like even in the classes, like we don't share the presentation. Okay, we share the study material that I could be possible from the resources from where I have made these presentations.
Sure, sir. Then
That
in
we
that
will,
case, you can share the study material. If you feel that
yeah,
the study material will be more helpful, then please share the study material. I think for
okay,
participants, I have also shared the link to the YouTube link to yesterday's sessions, so you can revisit that. and we will
Okay.
share the study material with you separately.
Where I will find that YouTube
Sir,
link?
I will just share the link on the chat window again. I have shared it during your session. I'm just sharing it again. Just a minute. Sharing it
Okay.
in the chat window.
And one thing more, you people perform any kind of rendering over that sessions, or it is as it is, just you upload that
Sir,
all the
as it
recording.
is. No, no rendering as it is. Sir, I've
Okay,
shared
no
the
cut.
chat window. No,
Okay,
sir.
because in the last we have discussed multiple things, so it may be possible if you cut it out. Okay, the sessions is not that long. Okay, it is up to you.
Okay. Sure, sir. For the webinars also, like we have every Wednesday we have webinars. So in the webinars also
Okay,
actually include the question and answer round also. So I think
no
it
problem.
is fine. Yeah.
Okay, no issue.
Okay. Okay. Thank you, sir.
Okay, we will meet at 12.
Sure, sir.